Hello everyone, welcome to Omega Chemistry YouTube channel. Your encouragement means a lot to me by motivating to do more videos. So please subscribe, push the notification bell and introduce this channel to your friends also. Okay, thank you for. In this session we are going to learn a very important part of isomerism. This is to find out total number of stereoisomers for a given organic compound having more than one asymmetric center. We know what is an asymmetric center is. If a carbon is attached to 4 different atoms or groups, then I can call this carbon as asymmetric carbon, right? Asymmetric carbon. Asymmetric center or whatever. And since it has only one asymmetric center, I have only one D isomer and one L isomer. Of course, we know what is a D isomer and L isomer, and D and L isomers are optically, they are mirror images of each other. And since I have only one asymmetric center, no mesoform will be present. Meso isomer is an isomer in which if a molecule is divided into 2 equal parts, one half of the molecule will be the mirror image of another half. In that case, one part will act as a D isomer D and another part will be acting as a L isomer. So there comes an internal compensation. That's why the molecule will be optically inactive. Still it is an optical isomer, right? So we are going to find out how many D isomers and L isomers. Totally I will call them as enantiomers, right? And how many mesoisomers are there. Put together enantiomers plus mesoisomers will give me the total number of optical isomers, right? So we are going to calculate how many total number of optical isomers are available in a compound that contains more than one asymmetric center. Let us take this example of lactic acid, and lactic acid contains only one asymmetric carbon, right? And here I have shown you the D isomer and L isomer, and from this you can understand that the D isomer is a completely a mirror image of L isomer and vice versa, right? So total number of enantiomers, that is D isomer and L isomer, will be 2. Since there is only one carbon, there will be no mesoform available. So total number of optical isomers available for this compound will be 2. So using the following rules, we can able to find the number of optical isomers. So the rules have been tabulated over here for your benefit. And the first rule goes like this: if a molecule has no symmetry, okay, we are going to look at examples for each case. If the molecule has no symmetry, then there will be no mesoisomers and the total number of enantiomers will be 2 power n. That is going to be the total number of optical isomers. And if the molecule has symmetry and n is going to be even number. Now you may ask me, what is n? N is nothing but the number of asymmetric carbons, right? Asymmetric centers. If the molecule has symmetry and if n is even number, then the total number of enantiomers will be 2 power n minus 1. And total number of mesoisomers will be 2 power n by 2 minus 1. Okay, so the summation of these two will be the total number of optical isomers. Whereas the molecule has symmetry, and if n is going to be the odd number, then this is the formula: 2 power n minus 1 minus 0.5 into n minus 0.5. So this part, okay, this part is nothing but a meso part, okay, and if you add these two, they will get cancelled, and the total number of meso optical isomers will be 2 power n minus 1 only. Now let us take this example. So we have a compound over here, and this is an asymmetric carbon. This is going to be an asymmetric carbon. This is also a symmetric carbon, and this is also a symmetric carbon, right? And if I cut the molecule exactly at the center over here, then the left side is not equivalent to right side. Am I right? So I can say the molecule doesn't have any symmetry. So which means it will fall in the first case. So here n will be 4, right? 4 asymmetric carbons are there, right? Now the formula for this one is A is 2 power n, right? Which means 2 power 4. 2 power 4 means 2 into 2 into 2 into 2. 2 into 2, 4. 4 4s are 16. Which means the total number of enantiomers, that is D and L isomers, will be 16. And since the molecule don't have any symmetry, there will be no mesoisomer. So meso isomer won't be available. So total number of optical isomers will be 16. Now let us look at the next example. Here we have a molecule, and let us count the number of asymmetric centers. 1, 2, 3, 4, 5 and 6. So n is 6 for this molecule, and if I cut exactly at the center, then 1/2 is exactly the mirror image of another form. So I can say that the molecule has symmetry, and n is even, so it falls in the second category. In that case, the total number of D and L isomers will be 2 power n minus 1, which means 2 power 6 minus 1, that is nothing but 2 power 5. So 2 power 5 is nothing but 2 into 2 into 2 into 2 into 2. So 4 fours are 16, 16 plus 2, so totally 32 isomers. And the total number of meso isomers will be 2 power n by 2 minus 1, right? So 2 power 6 by 2 minus 1, which is nothing but 2 power 3 minus 1, which is nothing but 2 power 2, that is nothing but 4. So total number of meso isomers will be 4. So total number of optical isomers will be the summation of this 32 and 4, which means 36. Now let us take the third example. Okay, let us count the number of asymmetric carbons. This is an asymmetric center. 1, 2, 3, 4 and 5. So here n value is 5, and if I cut the molecule exactly at the center, the molecule has symmetry, which means it falls in the third category. The number of asymmetric centers is an odd number, 5. So the total number of D and L isomers would be 2 power n minus 1 minus 2 power 0.5 n minus 0.5, which means 2 power 5 minus 1 minus 2 power 0.5 into 5, okay, minus 0.5. So that means 2 power 4 minus 0.5 into 5 is 2.5. 2.5 minus 0.5 is 2. 2 power 2, which means this is 2 into 2, 4. 4 into 4, 16, right? 16 minus 2 power 2 is 4, which means this is 12, right? So the total number of D and L isomers will be 12, and total number of meso isomers will be this part. This part is nothing but the total number of meso isomers, that is 2 power 0.5 n minus 0.5. So that means 4 is the total number of meso isomers. So which means total number of optical isomers is, you need to add this 12 and 4, which means it is 16. Now these two problems for your practice. Okay, observe the problem and work out. The answers will be given in the comment section. Thank you guys. Happy learning.